In this video, I'm going to go through the Chapter 1 review problems for the semester review for Algebra 1. So I'll do the first 6 problems because all of those problems refer to Chapter 1. Now, if you remember Chapter 1, what we did is we classified numbers, so that's going to ask you to do a couple things here. We also did combining like terms in the distributive property. And what you need to know is the set of numbers for question 1 and 2. Now, the real number system has, let me see if I have a blank here. The real number system has 2 categories, rational and then irrational. Rational numbers are numbers that can be written as a ratio, meaning a fraction, and irrational cannot be written as a fraction. And here's why. These fractions as a decimal stop or repeat, so think 1/2, that decimal 0.5 stops, or 1/3, that decimal repeats, versus irrational numbers when they have a decimal that never stops and also never repeats. You have something like pi or the square root of 2 or square root of 3, but not the square root of 4 because that simplifies down to a whole 2, which would be rational. Now within rational there are non-fraction numbers which start in the category called integers. And these are all of your negative numbers like -5, -4, -2, 0, 1, 2, 3, all the numbers that are whole, negative or positive. Now, within integers is a smaller subgroup called whole, and that starts at 0 and strictly goes up. So I should put a couple dots here to let you know that that keeps going. And then within whole, there's a subgroup called natural, which starts at 1 and strictly goes up. So natural is a part of whole, and whole is a part of integers, and integers are a part of rational, and rational are part of reals. So if you classify a number as natural, you have to classify it as all the other groups that it belongs within, because this is a subgroup of whole, which is a subgroup of integers, which is a subgroup of rational. Hopefully that kind of makes sense. And then both of those fit into real. So now that you kind of had a quick refresher on classifying, -15 is an integer, which makes it also rational, which makes it also real. Now over here, the number 45, because it's positive, it will fit into a couple other categories because integers include negative and positives, but a couple categories that are strictly positive would be natural, whole, then integers, then rational, and then real. So because this is a positive whole, it fits into natural, which is a part of whole and a part of integers, and a subgroup of rational and a subgroup of real. Now that we have decimals here, this could be written as a decimal, and this is already written as a decimal. This decimal stops, which would mean it's rational, and rational numbers are also real. Now this would be the decimal 0.6 repeating. So even though it's different than this decimal, this is a decimal part of rational which stop or repeat. So rational, and that is a subgroup of the real number system. So those two. Now for the next couple questions here, all you're going to do is combine like terms. Now in order to combine like terms, you have to have the same letter or no letters at all, so constant terms have no letters, or those letters have to have the same power. So if you'll notice, you have a couple x terms in here that I'm going to highlight, and the sign in front of your term goes with it. You have a couple y terms, so a -4y and a -9y, and what you want to do is combine like terms. So your 5x minus 2x, and then your -4y with your -9y. So if you combine the correct terms together, you'd have 3 x's and you'd have -13 y's, and that's our answer. Now again, for number 4 here, we cannot combine these two terms because they do not have the same letter, nor do they have the same power, but what we are going to do is substitute in for the letter x the number -4, and substitute in for the letter y the number 5. So 2, and now in parentheses my -4. I'm going to take my -4 times -4. That's what square means. so 2 times 16, and then I'm going to subtract 3 times y, which is 5, or subtract 15. So 2 times 16 is 32, and 32 minus 15, maybe you want to quick grab your calculator, is the number 17. For number 5, we're going to do the distributive property and then also combine like terms. So I'm going to start by distributing my 3 to my 2x to get 6x, my 3 to my minus 6, or minus 18 then. I'm also going to distribute my minus 9, so minus 9x here, and distribute my minus 9 to my minus 1. Well, a negative times a negative is a positive, and that's going to make 9. Now again, like we did for number 3, you want to combine terms that are alike, meaning they have the same letter and the same power. So my 6x and my minus 9x would be a total of negative 3x. And then my negative 18 plus 9 together is going to make minus 9. So negative 3x and minus 9. For number 6, again, you want to distribute. So take 4 times 2y, or 8y. 4 times negative 4, or minus 16 with that letter x. Now distribute your negative 7, so negative 7x, and distribute your negative 7 here to get negative 42y. Now again, we're going to combine like terms. So my y terms, I'm going to put those together, and that includes the sign in front of your coefficients, on front of the number. So 8y minus 42y. And then we're going to combine our x terms together here. The negative 16x minus 7x more. So total here for my y's, I have, if I use my calculator, 8 minus 42 is going to be negative 34y. And if I combine my x's together, I'd have negative 23 x's. Now normally you would leave your answer in what's called standard form, so your letters would go alphabetically. Technically this would be correct, but standard form would be negative 23x minus 34y, because we normally put our variables in alphabetic order for our final answer. And then for this question, I didn't specify the order. You could write negative 9 minus 3x, but because we're working with, now currently in Chapter 5, our linear functions, that y equals mx plus b function, you want to put your letters first and your constant, meaning your number term, last, and your letter terms should go in alphabetic order as well.